So applications of quadratics, we've talked about how to solve for these, the vertex, the y-intercept, and the x-intercept. So let's talk about them in an application sense. When we calculate the vertex, we are calculating either the highest or lowest height that the object is going to move. And so if they ask what is the highest value, we need to find the vertex and find the y value because that's height. If they ask for the time at which that happened, then we are solving for the x value of the vertex. Okay. You also have your y-intercept. Your y-intercept is your starting location of the object, whether it's going up or down. And you know it's the starting because the t value or x value is 0. So you're saying that's 0, no time has passed. So what's the height at that place? The x-intercepts are when the object are on the ground. So there should be 2 of them, a starting point. The object goes up in the air or goes down, under the surface and then comes back and ends somewhere. In both of these, you can calculate the time at which it took for an object to come back down to the ground or how long an object was totally in the air. And we know that we're on the ground because the h, or the height, is equal to 0. So remember when we're solving for vertex, if we're not in vertex form, we use negative b over 2a for the t value, which is now our x value is t, and then you plug in to get the h. For y-intercept, you will plug in t being 0 and then solve. And then for your x-intercepts, you're going to plug in h to be 0 and solve. And this is where you're going to need to factor, quadratic formula, something like that. All right, we have a pretty straightforward question. I'm going to ask that you pause the video and then you go and answer all of these questions on your own. They're very straightforward. You should be able to answer them. This is just making sure that you can read a graph. All right, max height right here. So the answer to question number 1 would be, what is the max height? The max height would be 100 inches. Question 2 asks, how long will it take the dolphin to reach the max height? So this is the point 2.5, 100. So the time that it takes, your t value is 2.5, and then your h is 100. How long does it take for the dolphin to re-enter the water? So right here is where it's re-entering the water. So 5 seconds. When will the dolphin reach 65 feet above sea level? Right here and right here. So we would say at 1 second and also at 4 seconds. And then lastly, at 2 seconds, how high is the dolphin? So we're going to make a good estimate of 95 feet. And then where else? It would be over here at 3 seconds. Okay? So let's apply some of the knowledge that we know to a real life problem. So this says a ball is thrown vertically upwards at an initial speed of 80 feet per second. Its height after t seconds is given by h is equal to 80t minus 16t squared. And then it's asking us to solve these things. The t-intercepts, the h-intercepts, the vertex, and then we can answer the questions, based upon that information. So the first thing that I like to do is I like to just sketch myself a little tiny graph of okay, if a ball is thrown up in the air and then it comes back down. Okay, so we know that we have a vertex, which is going to be a maximum. So I'm going to start by solving for my vertex. I do like to always put this in standard form so I know what my A, B, and C are. So to find my vertex, I'm taking negative b, dividing it by 2a, and that's going to give me 2.5. So I know my t value, or the x value, is 2.5. To find the y value, or h, we're going to just plug that in. So we have negative 16 times 2.5 squared plus 80 times 2.5. So we'll do a little calculation, and we get 100. So this point up here at the top of our graph, we can label as 2.5, 100. The next thing that we're asked for is, I'm going to do the h-intercept next. Remember, h-intercept is like saying your y-intercept. So to calculate your y-intercept, you just let, you plug in 0. So we know that t is going to be equal to 0 because we're finding that like starting value. So if we have negative 16 times 0 squared plus 80 times 0, we can plug that all in and we get 0. So our h-intercept is at 0, 0. Now we need to find our t-intercept. So in order to do that, we know that our h value, let me erase that. Okay, so we need our t-intercept. And we know to find our t-intercepts, we need h to be 0. So we have 0 is equal to negative 16 squared plus 80t. Now you can factor this a bunch. You can factor it. You could use quadratic formula. I would not complete the square here, and I wouldn't use square root method either. So I'm going to factor. I see that there's a GCF. So I can take out negative 16t. That's going to leave me with t minus 5. We take each one of our factors. We set it equal to 0. And solve. So we get t is equal to 0. And then t is equal to 5. So that leaves us with the point 0, 0, and 0, 5. So if I kind of go back to my sketch, I have 0, 0. I'm sorry, I wrote that wrong. We solve for t. Remember, t is x, so 5, 0. So here's about 0, 0. Here's 5, 0. We have to go to 2.5100, which would be pretty high. And there would be 2.5100. So when did the ball hit the ground? We're looking for time. So that would be 5 seconds. And I'm going back up and I'm looking at my units. When did the ball reach its maximum height? So our vertex, 2.5 seconds. What was the maximum height? Again, vertex, but the h value, th. So that would be 100 feet. What was the height of the ball when it was initially thrown? So we can tell that that would be 0 feet. Started on the ground. Okay. So you want to calculate all the things that you need, your vertex, your y-intercept, your x-intercept, and then determine what those are within the context of the problem. Remembering that x and t mean the same and h and y.